Linked list cycle 2. Giving a head of linked list, return the node where the cycle begins. If there's no cycle, return now. There's a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that the tail next pointer is connected to. Tail index is -1 if there is no cycle. Note that the position is not past this parameter. Do not modify the linked list. So here's the example. For example, we have this linked list. As we can see, when we add -4, we point back to 2. That means it's former cycle. And 2 is where the cycle starts. So we need to return this node with value 2. Another example, we have 1, 2, and 2 point back to the 1, and then we have a cycle, and the cycle starts from the node with value 1, so we return this node. And then if we have just a linked list with a single node, that means there cannot have a cycle. That means we will return now. And for this question, I'm gonna use a iterative approach. I'm gonna looping through the linked list, and I will have a 2 pointer, one slow and one fast. The slow pointer will be move 1 node at a time. The fast pointer will move 2 nodes at a time. Whenever they match each other, that means there's a cycle in the linked list. And then I will set the slow pointer to the head, and then I will start moving those 2 pointers 1 node at a time, and then whenever they meet, that will be the starting point of the cycle, and then I will return that node. Now we can implement the code. So first I will have a list node called slow, point to the head first, and then this node called fast, also point to the head first, and then I will have a while loop. So while we don't want to have null pointer exception, so well, fast is not equal to null, or fast the next is not equal to null. That means we didn't reach the end of the linked list. So like here, when fast is equal to null, that means we reach the end. If the fast.next is equal to null, that means we also reach the end, because we don't want to go to fast.next or next. That will give us non-pointer exception. And then I will start moving both pointer. I will move the slow equal to slow.next, fast equal to fast.next, and then if at some point slow equal to fast, that means they met. That means there is a cycle. And then if there is cycle, I want to set the slow pointer to the head, and then I will have a while loop. So while slow is not equal to fast, I will keep moving them 1 node at a time. So slow equals slow.next, fast equals fast.next. And then whenever the while loop breaks, that means they met. In that case, that's the node where the cycle started. So I will just return one of node. I will return slow. And then if we exit the outer while loop, that means we have reached the end of linked list. That means there's no cycle. That means we will return now, like the question asked. And then maybe we can lastly have some edge cases. So if head equal to now, or head.next equal to now, we will return now. Because if head is now, that means it's an empty linked list with no node. And if head.next equal to now, that means it's a linked list with one node. In both cases, there is impossible to have a cycle. So therefore, we will return now. And then next, let's analyze the time complexity. The time complexity will be O of n, because we use a while loop. And then for the space complexity will be O of 1, because we only create few variables which use constant space. Next, let's test this out. Looks like we passed the test.